Right, good day and welcome to today's stream on projectiles. We've got 4 interesting projectiles questions. The first one's not too bad, then it gets quite nasty on questions 20, 21, 22 in this revision series, which is designed to prepare for a specific test. And once the test has been done by my students, I will also post that in this folder for OneNote. Anyway, without further ado, here is the first question. I'll give you 7 minutes to tackle this. In fact, they're all 7-minute questions. Well, they're much more longer than 7 minutes, but 7 minutes is enough to tackle it and know what you do know and what you don't know about each question, so you can then watch the rest of the explanation that comes after. So, first 7 minutes, off you go. muted. I'm really sorry about that, being muted all that time. I knew I should have had my chat open earlier. Okay, let me just quickly pan back through this question again here. So I'm using the position here, the s equals ut plus a half at squared. That's my x position is given by my initial velocity in the x direction, 6. Okay, times by the t, and that's my initial velocity in that direction. And we're told at b that OB was equal to 2AB. So therefore, we got this distance here, x distance, is going to equal twice this y distance to get this equation here. And then I just go through and solve that equation. Now, when we come to velocity, we're going to use v equals u plus at. Now, the velocity in the x direction is 6. There is no acceleration in the x direction. So therefore, we just have 6 all the way through. The velocity in the y direction initially was 12, but it's affected by gravity, and that changes. So the velocity at time A, so I put the time into this at A. I think was it A? Yeah, it was at A. So at A, I put the time into here to get the velocity of y. So v squared equals the x part and the y part squared, rooted, and I've just gone through and solved that. So for part C, okay, at another point on C, the path of the speed of the ball is also v meters per second. Find the time taken the ball to travel from O to C. So basically, what we know is that so we know that basically the x doesn't change. So the velocity of y is the only thing that changes. So for it to be exactly the same velocity, when we know that vy, the magnitude of vy must equal 6 meters per second. Okay, it must be exactly the same. So therefore, we know that our velocity of y is given by this. So we know that 6 must equal 12 minus gt. Rearrange that, we get gt is equal to 6. Sorry, made a mistake there. So therefore, t equals 6 over g seconds. Okay, so let me just run through that again because it's a bit of a leap. Okay, so at the point, it's also v. We know that the x velocity doesn't change, so it's it's only the y bit that changes. Now, for it to be exactly the same, we know that the y bit must also, it was 6 squared here, so the magnitude of it must be 6. So therefore, we know that the velocity of y must be equal to 6, so we then can find out t. Okay. Now, actually, all the techniques I've used in this question, to do all the parts of this question, can be used to help us do this question, okay, except it's a bit more abstract. So I'm just going to zoom in on this question for you and give you 7 minutes to battle with this question. I've been through this with one of my sets yesterday. It's really quite a tricky question. Actually, what we'll do is we're going to split it up because it's a 17 mark. I can't really expect you to have a decent go at that in 7 minutes. So what we'll do is we'll look at the show that first, 3 minutes for you to have a go at that, and then I will then give you 7 minutes for the rest of the question. Right, learn from the mistake. Make sure I'm not muted this time. So I'm just going to zoom out so I can write beside the question. So this is a standard question here, although it doesn't look like it. And there's a nasty bit in here where you got ui plus cj, and you got your initial velocity effectively is ui plus ucj. And I know lots of people don't like the ij format. You can think of it as u and uc if you want. Okay, so you got your u component, and you've got there, and you've got your uc component going there to create your initial velocity. Now, when you're doing these, this is an equation of the path. You notice you've got y in terms of x. So effectively, that's giving us an equation of our path. And it's always a parabolic, it's always a quadratic. Okay, but sometimes it will have tans and things in it as well if they don't give you the angle. But we don't give you the component form of the velocity like we've got here. Anyway, let's move on. We're going to, you always start with S equals to ut plus a half at squared. Now for the x direction, we know that the u is equal to u, and we've got t. There is no acceleration due to gravity in the x direction. I'm going to keep repeating that so it makes it easy for you to remember. That's my equation 1. And then in the y direction, I know that I've got my u is going to be uc. I've got uct. And then I've got my acceleration due to gravity is going to be minus g. So I've got my acceleration is minus g. Put that over 2 t squared. And that's going to be my equation 2. And what I'm going to do is substitute into, I'm going to rearrange equation 1, sorry. So let's just change equation 1. So I'm going to make t the subject. So I want to eliminate t. There's no t's in here. It's all y's and x's and u's. So as long as I can get rid of the t's, then I can get that equation. So I get x over u. Okay, so probably should call that, if I was being really specific, I'll call that equation 3. And I'm going to substitute 3 into 2. So everywhere there's a t, I'm going to replace it with x over u. So we have y equals uc. Now t is equal to x over u, so times by x over u, minus g over 2 times x over u squared, because t is equal to x over u. So therefore y will equal, the u's cancel, so I've got cx minus gx squared over 2u squared. But they want a 4.9. Now g is 9.8 divided by 2 gives me 4.9. So y equals cx minus 4.9 x squared over u squared. So, okay, well, we can use this part answer A to do part B. Then on part C, I'm going to leave you to do both part B and C yourselves. Part C, think about gradients to help you with the right angle part of it. Think about gradients. Gradients can help you. The idea behind gradients and what makes gradients perpendicular can help you do part C. So I can give you 7 minutes to have a go at the question. Now. Right, if you managed to get this one out, you've done very well indeed. Part B, not so bad, but part C is a tricky question. So we're told that, sorry, I've just told my answer. So let's look at this. So we're using the result in part A, if I was finding terms R. So now we know at R that the Y, if we draw a little picture of our projectile here, there's our initial projection, then point R is obviously where it hits the ground, so therefore Y will equal 0. We also know that U equals 7 in this case. So we're going to put that into our equation. So we're going to get 0 will equal Cx minus 4.9 x squared over U squared 49. We can rearrange that. Let's just give ourselves a bit more space for all the working we're going to need to do. There we go. And we get, so that's going to be 1/10, just to tighten this out by 10 to make life a little bit easier. I'm not a big fan of fractions. And we get that. Factorize it out. And we can see that x equals 0 or 10c, which is good because obviously x equals 0 when we start and we're at 0 on the y. And then this must be the point 10c, so r will equal 10c. Okay, part 2. Now, there's two ways to do this. You can either look at the tricky ways to look at when the velocity equals 0, because that gives you maximum height, or realize that this is symmetrical, okay? Parabolic flight in the A-level maths course, we don't have any air resistance, so the only thing changing it is gravity, so therefore it's a symmetrical graph. So we know that this is going to come at the midpoint, so if r equals 10c, then the x value at this point will equal 5c. So we can just substitute that into this equation. So we get y equals, put 5c into that, we get 5c squared minus, we know that 4.9 over 49 is going to give me 1/10. So we've got 5c squared over 10. And that just gives me 25c squared divided by 10 is 2.5c squared. So take that away from that and we get y equals 2.5c squared. Now for part C, what we've got is, given that when P is at the point Q, the velocity of P is at right angles to its initial velocity. So there's its initial velocity, and we know point Q, somewhere over here, is going to be at right angles to that. Now we know the initial velocity was equal to U over, U for the x displacement and UC for the y displacement. So therefore, if the gradient of that, or the slope of that line, is going to be UC over C, then this one must be minus C over UC. Okay, so, sorry, not UC over C, apologies, that's a U there, because the x distance was U, so that would be minus U over UC. So we can do that in this way. So our Vx is always going to be U, but we need these going to be in the ratio, okay, U over UC. Okay, so Vx we know is going to be a velocity x initially at any point is always going to be U. It doesn't change. Okay, so although we're going to get this gradient to be minus U over UC, we can't have the change in x to be UC because the change in x, the velocity, is always going to be U, but they're going to be in ratio. Okay, so if we know that we got, let's just put out Vy over U, and we know that the ratio of this has got to be equal to minus U over UC. We can see that Vy will therefore equal, if we times that by U, we're going to end up cancelling out of U. It's going to be equal to minus U over C, is what our Vy is going to be. Okay, so we're going to make our Vy equal to minus U over C. Now we're trying to find the value of x, the position at this point in time. So we know that our position of x let's just use this to find our t first. We're going to have to find the time that this happens at, because we know our position of x is given by x is equal to u times t, and we need to find the time that this happens at. So we know that v equals u plus at. Now, if I'm going to be doing in my y's, okay, I know that my y velocity at this point is minus u over c, and I know that the initial velocity was equal to uc in the y direction. And I got minus gt here. Let's rearrange this to get gt equals uc plus u over c. And therefore, my t value is going to be equal to 1 over g times, let's take this u out actually, times c plus 1 over c. That's my time at which this happens at. Remembering that the x component is going to be equal to u times t. There's no acceleration happening. So therefore, my x component is going to be u times t. So I'm going to get u squared over g times c minus 1 over plus 1 over c. U squared is equal to 49 divided by 9.8. That's going to come out as 5c plus 1 over c. Really quite nasty question, this one. So not only have you got to appreciate that the gradients are going to be in this ratio, you're going to realize that you can't just replace the top, the change in y with u, and the x with the uc, because actually the x component is always u all the way across. So therefore, the y divided by the x has got to be in ratio to got to be equal to that. So v divided the y part divided by the x part has got to be either minus u of uc, and you've got to find out what the vy is from that. So that was the probably not this was this bit. Hopefully, most of you guessed, but this bit was probably the tricky bit to work out, and then to shove it all in and get the right answers out. Really quite nasty. If you get this out, this is about as hard as it can get, I think, on a projectiles question. Right, we're only going to attempt to do one more question because this has been a long stream so far. So we'll do this one because it sets up to allow us, and it's also the question that most of my students wanted to do. If you can do this question, question 21, you'll be able to do question 22, okay? But I will just flash up my answer to the screen, question 22 anyway as well. So let's just give you 5 minutes to play with this question, then we'll go. Right, here we go. So we've got a child playing cricket on horizontal ground, hits the ball towards a fence 10 meters away. The ball moves in the vertical plane, which is perpendicular to the fence. The ball passes just over the top of the fence at 2 meters per ground. When it says it just passes over the top, you can assume that basically the ball goes through the point that's 10, 2. Okay, if you go 10 along and 2 up. And you can use that in the rest of the question. So we're going to start off by, let's just zoom out and give myself some space. Wrong way. Okay, so I'm just going to rub out this working here. Give myself some more space. We're going to, part A, we're going to start off with, like we normally do when we're doing these equations of the path. You should see that this is now, from the questions we've been doing, that this is a typical format for the equation of the path. So we're going to use S equals to UT plus a half AT squared. And we're going to look at the X part. And now the X part, we don't know much apart from it's U meters per second for the initial velocity and angle alpha. Well, we're going to use alpha. I think that's meant to be an alpha because there's an alpha here and there's an alpha there. That should have been an alpha. So we've got U and we've got alpha here. So X will equal U cos alpha times T. The U displacement is U cos alpha times by the T. There is no acceleration in the X direction as we've said before. So we can see from this that T will equal 10, because we know X is 10, over U cos alpha. Then for the Y bit, so we've got the Y component is equal to U sine alpha. Okay, this part is going to be equal to U sine alpha minus G over 2T squared. Now we know the Y value is equal to 2, so I'm just, rather than write out the equation again, I'm going to chuck the 2 straight into it. So we've got U sine alpha T minus G over 2T squared. Now I can replace the T's, like I did before, with the 10 over U cos alpha. So I get 2 equals U sine alpha times by 10 over U cos alpha. We can cancel out those U's while we're here. Minus G over 2 times by 10 over U cos alpha all squared. Now let's multiply this out. So we get 2. So we're going to get 10 tan alpha, which is nice, what they got there. It's annoying that they got the A and they got the alpha there. Sorry about that. I didn't spot that. I just assumed it was all alphas. I hope you did too. So what we're going to get, 10 squared is 100 divided by 2 is 50 G, and then we're going to be over U squared cos squared alpha, which we've done. Now we're told that alpha equals 45 degrees. Find the speed at which the ball passes over the fence. And this actually comes out to be a bit longer. The only nasty bit about this is just the numbers aren't very nice, really. So if we got alpha equal to 45, then we can put that into this equation. So if we've got alpha equal to 45, then tan alpha is equal to 1. So we get 2 equals 10 minus, and we've got 50G, and then we've got U squared, and then cos of 45 is going to be root 2 over 2 squared. That will give me a half. And then I can take away the 8. So I'm going to get 8, change the signs at the same time because I've got minus here and a minus there. So I'm going to get 8 is equal to 100. 50 divided by half is 100 G over U squared. Rearrange that to get U squared is equal to 100 G over 8. And it doesn't come out to be anything particularly nice, the U here. So U would equal 11.1 meters per second. Or you can, if you want an exact form, you get 7 root 10 over 2. Now, that hasn't found the speed at which it passes over the fence. That allowed us to find initial velocity. Okay, it's only just allowed us to find initial velocity. So we've got to do a bit more work. And we've got to look at the point 10, 2. We can find the value of T, because we know the value of T equals 10 over U cos alpha. So T will equal 10 over 11.1 times the square root of 2 over 2, because cos alpha is square root of 2. Okay, I'm just going to leave that in there for now. My x dot, sorry, let's not use the same notation we've been using. X dot's another version of the velocity in the x direction, so I'm going to use v in the x direction. Will be equal to u cos alpha, and my v in the y direction is equal to u sine alpha minus gt. And I've got to use these two to find the speed at which it passes over the fence, because I find the velocity at which it passes over the fence and take the magnitude of that, and I get the speed. Now, if you ever want to work out the direction at any point, we haven't covered that in any of these questions. The direction is given by the components of the velocity at any point in time. To always work with velocity. A big mistake here is to work out the position. The only problem is the position gives you that, okay, relative to the origin. You always got to work out velocity, but I just thought I'd mention that for future reference. So we can find Vx, and I've got actually the exact values for this. So we're going to use the 7 root 10 version over 2 times root 2 over 2 to get 7 root 5 over 2. Okay, because we got our u down here, 7 root 10 over 2. So I've used that. Cos alpha is equal to root 2 over 2. So we've got our Vx. Vy, u sine alpha is going to come out as 7 root 5 over 2. We've got minus g sine 10 over all the gubbins, 11.1 times root 2 over 2. Okay. T was equal to all of that, so we're going to just put that into there. I've forgotten the sine alpha is root 2 over 2 here, isn't it? Okay. Oh no, I haven't forgotten it, because essentially cos alpha is the same as sine alpha, so actually this component comes out to be the same as that component because it's 45 degrees, not a surprise. So no, I have already included that. I hadn't forgotten it, because all I've just done is taken this, because it's going to be exactly the same, because I'm still going to have u cos alpha there. U sine alpha will be exactly the same, because at 45 degrees, sine alpha and cos alpha are exactly the same. Right, so where are we up to? So we can simplify all of that to Vy. When you put that all into your calculator, comes out as minus 21 root 5 over 10. And just shove that all into the calculator, get an answer out. Therefore, V will equal the square root of our Vx squared plus our Vy squared. When you've put that all into your calculator, so you square that, add that to the square of that, you get, I think, the square root of 833 over 10, or 9.1 meters per second to 2f. And I think that deserves a little frost. Finish. Okay, so I'm not going to go through the last question. I'm just going to I'll post up my answers which I did before. So there is my answer to the last question. You can take a screenshot of that, or you can download the notebook and find it there. Okay, because in the notebook there's a blank version of this question, which is the sheet I just did, or you can look at this version of the question. So hope that was a bit of help. Good luck with learning that and having a go at this question. If you could not do these questions straightforwardly, then what I suggest you do is you save them and have another go at them in a week's time, okay, to check you can still do them. Or go through the video again in 2 weeks' time, or 3 weeks' time, or a month's time. That's another way to improve your problem solving, is actually do the difficult questions again so you can remember the patterns of problem solving that occurred. Anyway, thank you, and that will be the end of the stream.